So one of the things that is in this lesson that we're not going to do is graphing cube roots. We're just going to be doing graphing the square roots. So we haven't done any of the cube roots, so we're just going to be doing the square roots. So if you take a look at the essential understanding down here, part of this involves like inverse functions, which is a piece that we're skipping and going back to. So just kind of a general idea. So we know that when we look at this shape here, this is a parabola, right? So this is a parabola we're used to graphing. But they also can have sideways parabolas, which we didn't study and we haven't graphed. Okay? So what we're going to be doing, though, is our square root functions. And so this is our parent function here. So we're going to be working with this graph right here. So that's the graph that we're going to be doing. So that's our parent function for us. Okay, so that's what all of our graphs look like. So I'm going to do it up in the blank space up here as well so we can see it and make sure we see that part. So for our parent function, so y equals the square root of x. That way we can kind of see it a little bit easier. The graph is just going to be half of a sideways parabola. Okay, half of a sideways parabola. So I'm just going to count out to 4 on my x, and then up to 3 on my y. So the parent function has that vertex, so the vertex of a parabola is at the origin, 0, 0, so that means it's not shifted. And so I'm only going to plot a few points, and I'm only going to plot the points I know the square root of. So 0 is substituted in already. So what else do I know the square root of? I know the square root of 1, right? So I'm going to plot when x is 1, y would be 1, because the square root of 1 is 1. Okay? So what else do I know the square root of? I don't know the square root of 2. I don't know the square root of 3. I do know the square root of 4. So if x were 4, so 1, 2, 3, 4. So if x were 4 and I took its square root, that would be 2, so I would go up to 2. And so that's my parent function. So when we're graphing our graphs, we're going to want to make sure the numbers that we choose for x are going to be square root numbers. Okay? And so then now, just in general, we're going to do domain and range as well, because we're going to need to know that for the worksheet. So for domain and range, domain is the left to right. Right, so left to right, so we go from left to right. So how far left does the graph go? So where does it start, and then when does it stop? Okay, so it starts at 0 and stops at infinity. So we go from 0 to infinity, and then do you guys remember when do we use brackets, when do we use parentheses? Yep, so this is closed on the 0, open on the infinity. Okay, so closed on the 0, right, because it equals 0. And we can't ever equal infinity. So then for our range, do we go top to bottom or bottom to top? Bottom to top. Okay, so how low is the graph? How high is the graph? So the high part gets confusing sometimes because of the way it looks. So for sure the bottom's easy, right? It looks like the lowest is 0, so it starts at 0. So now, as far as the range for how high does it go, when I look at this graph, it looks like, oh, that's as high as it goes. It doesn't go above, like, say, 3, right? That's the way it looks, but that's not what the graph does. It is always going up and to the right. It doesn't look like it, because even when we draw parabolas, I get lazy even with parabolas, and I make them look like they go straight up and never grow outwards, but they do, right? And that's the same thing with the square roots. It's very slow, but it definitely is always going up, 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 right? It's just easy just to go, whoop, call it good. Okay, so even though it doesn't look like it, it is always going up to infinity. So we'll do same thing, so from 0 to infinity. So one of the things that we need to make sure we're always paying attention to on our square root graphs is there should always be one of these be infinity, one of these be infinity. Okay, so we need to remember that. Okay, they're always growing forever in one of those directions. Okay, so there's our domain and range. The other thing we're going to have to remember is increasing and decreasing. Okay. So that was objective, or unit 2. So increasing meaning we're going, when are we going up, right? So where are we going up? So if I look at this graph, and I always read it from left to right, Am I increasing or decreasing? I'm increasing. So my increasing is the same as the domain, right? So from 0 to infinity, I'm increasing, I'm going up. So when am I decreasing? When am I going down? I'm not, right? So I just write never, or you can do like a no solution if you want to, but it's never decreasing, okay? Now, it doesn't mean that you'll never have a square root that will be decreasing. It just means for the parent function, we're not ever decreasing. Because remember, we can flip our graph, so if I flip it upside down, then it's decreasing, never increasing, okay? All right, so there's our parent function. So now we're going to switch to the second page here. So look at some key concepts. So these are our families of our radical functions. Okay, so we're only doing the square root, so we won't be doing like cube roots or fourth roots, which is all of this over here. And so some of this language and some of the way they write it is going to look the same, similar to what we're used to. So we know the parent function is the square root of x. And then if I make it negative, it reflects on the x-axis. So I'm just going to squeeze that in right here just so I can have like a basic shape of a graph. So if it's square root of x, just like that, I know that's what the basic graph is going to look like, right? But if it's negative, that means it's going to reflect along the x-axis. So that means all my y values are negative. So that means it's going to be that way, okay? So I just have those drawn in there just so that I can remember that that's the basic shape. So if it is negative, it should be going downwards. If it's positive, it should be going upwards, okay? And then we're used to seeing this word, the stretch, right? So the stretch is something that we're used to seeing, and so that's the number in front here, right? So if it's a line, we call it a slope, but everything else we call it a stretch because it's not consistent, okay? And so we're going to use the stretch the same as how we know how to use it. So we already know how to use our stretch. And then our translation, so we're going to use h and k as well. So they write it in this form right here, right? But we know that if it's grouped with the x and the radical counts as a grouping, then that's affecting the x, and we called that h. But now how do I know that this k out here, this is my straggler number, it's really affecting the y? So when I write it, we normally subtract it over, right? And so then my vertex will be hk. Okay? And now some of us did that in our heads, right? Some of us just move the number over and then know to do opposite. So we always need to remember that whatever that straggler number is, it's not with the x, it should be with the y. So when I do this, then I move it over so it's with the y, so I know it's affecting the y. And then when I do my vertex, it's the opposite here and the opposite here. Right? Okay, so let's go ahead and do a couple of examples here. Okay. So we're going to do graphing. Okay, so what are the graphs of y equals root x plus 2 and then y equals root x minus 3? So we're going to do this one here first. Okay, so when I look at this, for this plus 2, is it with the x or should it be with the y? It should be with the y. Okay, so I'm going to subtract the 2 over to the other side. Okay, so then I have really y minus 2 equals root x. Okay. So then I figure out, okay, what's my vertex? Where do I start? So I look to see, okay, what's affecting the x, what's affecting the y? So if I look in here with the x, am I adding or subtracting anything to x? No, so then I just use 0, right? And then do I have a number with the y? I do. So should I be using 2 or should I be using negative 2? I should be using 2. Okay. So there's my vertex, 0, 2. Okay. So then I'm just going to draw an xy axis. Okay, and then I'm going to plot my vertex, so over 0 up 2. Okay. And then I need to plot additional points. Like I can't just plot 1 point and then call it good. Okay, so I always want 3 points plotted, a vertex plus 2 more. Okay, so when we graph these, when we do the vertex plus 2 more, so that's always a requirement. And I'm not going to do this problem over here, so I'm going to write in this space over here on top of my graph paper because I'm not going to use that. Okay, so we always want to graph the vertex plus 2 more. And when I choose those 2 more points, I always want to make sure they're numbers I know the square root of. Like I don't want to choose an x value I can't square root. Okay? So usually if you choose numbers you want to square root 0, you want to square root 1, you want to square root 4, right? Those are the numbers you know. Your vertex is always going to be, you know, whatever your shift is. So it will always generate the square root of 0. Not that x is 0. That doesn't mean x is 0. It just means the result is 0. And then your plus 2 more points, so I'm going to call it 0.1, 0.2, are going to be from the square root of 1 and then the square root of 4. Again, it doesn't mean x is 1. It just means the result is 1. Okay? And we'll see an example of that here in just a minute. So for me, when I do my t-table, I need to figure out what x value am I going to choose so that I get the square root of 1. So I get the square root of 4. So the first one we do is easy. So if I look up here at the original problem, what do I want x to be? So I'm square rooting 1. I want it to be 1. What does x have to be so that I square root 4? I want it to be 4. Okay. So now let's plug in 1. So I'm going to plug 1 into the original problem. So what is the square root of 1? It's 1. And then plus 2. So that would be just 3. So it's the square root of 1 plus 2, which is 3. So now for this one, it's the square root of 4 plus 2. So that would be 2 plus 2, which is 4. And so now I'm going to plot those points. So I'm going to go over 1, up 3, and then over 4, up 4, 2, 3, and then there we go. Okay, and there's my graph. Okay. All right, so I want you guys to do number 1 right now. Okay, so you guys do number 1 for me.